We have a block. This angle here is phi. Remember that the block is initially moving with a speed v naught on a frictionless horizontal surface. The implication of the fact that it's frictionless is that the speed is the same. Please stop throwing things around. Now the block slides up an inclined plane. Remember that, please look up. Some of you reasoned that since the block is sliding up the inclined plane, there should be a force pulling the block up the inclined plane. No, there isn't.
That's false.
So what we need to do is draw the free body diagram. This is mg. This is, the normal force. And since it's going up, the friction force is acting downwards. Now, one thing you should also recognize is the fact that the weight has a component. This is mg cosine theta. And this is mg sine theta. And I've chosen my axis positive upwards. Yes, please?
So you chose your axis to be along with the inclined plane?
Yeah.
It is better in general to do it like that, or to do it like maybe inclined plane straight and then slant of gravity?
No, it's better to do it like this because you still treat the block as if it's on a level surface. If you, for some weird reason, or you like a lot of work, decides that your coordinate system is like that, you realize that your coordinate system itself makes an angle with what? The plane. And therefore you have to resolve the coordinate system, and then you have to do what? Solve the problem in your new coordinate system, and that involves matrices and transformation, and we don't want to get into all of that.
So I mean, we did it like this to make the x and y alignment.
Good. Then that is what I do recommend for everybody to do. So look up, everybody. For case 1, remember it says that you should draw the free body diagram, and this is given. All I needed from you is 3 forces, one acting vertically downward, the weight, the other acting perpendicular to the plane, which is the normal force, and this is Fk. You could do it like that as well. I don't mind. So this is the free body diagram for case A. Now the next question is for us to calculate the acceleration of the object. First of all, we recognize that f of y is 0, which means that n minus mg cosine theta is equal to 0. Recall that this is in page 352 of the textbook. So this implies that n is equal to mg cosine theta. Next, you know that the summation of fx is equal to ma, which means that you have 0, there is no force acting along the direction of motion, minus mg sine theta minus fk. All of this should be equal to ma. Now I'm going to move to the next page. So we now have negative mg sine theta negative mu kn is equal to what? Ma, which would mean that negative mg sine theta minus negative mu n mg cosine theta is equal to ma. The m's cancel, and the acceleration a would be equal to negative g bracket sine theta plus mu k cosine theta. This is the acceleration of the object up the inclined plane. That is the acceleration of the object up the inclined plane. The next question is to determine the acceleration of the object down the inclined plane. If you look at the situation down the inclined plane where the object is moving down, it's a little bit opposite. This is mg. Now the friction force is acting in the opposite direction. That is Fk. The normal force is always perpendicular. This is N. As usual, yes please.
Does the normal force come from the ground?
The normal force is the contact force that the surface exerts on the block.
Oh, right, okay, so it wouldn't be like the center, like...
Yeah, it comes from here. Look up, it begins here. Now we can resolve the weight into two components. This is phi. This is mg cosine phi. And this is mg sine phi. So you recognize that the summation of Fy is equal to 0, which means that N is equal to mg cosine phi. And we also know that the summation of Fx is equal to ma. Remember that this is x, this is y. So this means that negative mg sine theta plus f of k will be equal to negative ma. Therefore, negative mg sine theta plus mu k mg. Now this is phi, not theta. All of this should be equal to ma, negative ma. If we multiply both sides by negative, you're going to have ma should be equal to mg sine phi minus mu k mg cosine phi. The m's can carefully cancel each other, and the acceleration is going to be equal to g sine phi minus mu k cosine theta. This is the expression for the acceleration of the object down the inclined plane. Now the question is to derive an expression for the distance traveled by the block up the inclined plane. Initially, look up everybody, v naught is equal to v naught at x naught equal to what? 0, and at t equal to 0. So we know that x is equal to v naught t plus half a t squared. But the question is, do we know the time of the inclined plane? No. We also know that v f squared is equal to v naught squared plus 2a delta x. When it reaches at maximum height, this guy is 0. Therefore, delta x, which basically is just x minus x naught, and this is 0, is equal to what? Is equal to negative v naught squared divided by 2a, which will be equal to negative v naught squared divided by negative g bracket sine phi plus mu cosine phi. The negatives can take care of each other. There is a 2 here. As a result, x will be equal to v naught squared divided by 2g bracket the sine of phi plus mu cosine of phi, and that is the answer I expected from you. Now the next question is, please copy, and if you have any questions, ask. Part C of the part E of the question says, who had this correct? Put up your hand, let me see. Who got this right? Okay, now part E of the question says, determine how long it takes for the block to slide up the inclined plane, stop, and then slide down the inclined plane until the instant it's moving with speed v0 pointing down the inclined plane. Now, we are going to make a fundamental assumption here. We are going to make a fundamental assumption here. And the assumption is that it doesn't, when it goes up and stop, it immediately starts moving down. It does not delay. You understand that, right? So for us to be able to do that, there are two ways we can do this. We can calculate the time up the inclined plane and the time down the inclined plane, which is easy. We know that V is equal to V0 plus AT, so which implies that for the motion up the plane, we have 0 equal to V0 plus AT up, which means that the time up will be equal to V0 divided by U up. Therefore, T up will be equal to V0, which is, there's a negative here, divided by negative G bracket sine phi plus mu cosine phi. The negative sign cancels out, so T up is 0 V0 divided by G bracket the sine of phi plus mu the cosine of phi. This is the time up the inclined plane. For the time down the inclined plane, V0 is 0, V final is V0. Do you understand that, right? Because it comes to rest and then it accelerates. When it gets back to where it started, the final velocity is V0. It's kind of reversed. This means, this implies that we will have V0. Remember, it's in the opposite direction, so this is going to be negative. All of this will be equal to 0. Yes, please.
So I just have a quick conceptual question, and it's probably like completely stupid, but if you have friction on the way up and on the way down, how can the final velocity equal the initial velocity? Like, aren't you losing energy to heat and other things?
Listen to the question. It says,
I mean, it says that you're going
it says that slides down until the instant it is moving with speed v0 pointing down the inclined plane. So it's clearly stated. You understand that, right? Now, if the ram is short, that is impossible to happen. If the ram is long, it can happen. If the ram is tilted, if the angle theta is high enough, it doesn't matter the friction. You understand that the acceleration will be high enough for it to gain back its original speed. But because phi is really not defined, so we are free to make that assumption.
Regardless of losing to heat, the friction is pointing in opposite directions.
But I'm saying, like, you have some energy, right? And you're losing that energy. You can't just, there's no extra energy putting it down.
Still the same amount of time.
You gain energy through gravity.
But no,
That's how it's explained.
you need to invest energy to gain.
Now, what Clement is saying,
Time is unaffected by that.
we will discuss the details of, listen please, let's not waste too much time on this. We will discuss the details about energy conservation and stuff after this chapter, because that's what we are going to be moving forward to. But for now, let us stick and do the problem. So we have here, remember that the acceleration down is given by this. This is negative AT down. It's negative because it's pointing in the negative direction. So we have T down equal to V naught over A down, which is just going to be V naught divided by G bracket sine theta minus mu K, no, sine phi minus mu K cosine phi. This is the time up and this is the time down. So the total time, T total, will just be T up plus T down, which will be V naught bracket 1 over V naught over G, 1 over, this is phi, plus 1 over you can simplify, which is easy to do. And to simplify, it's not that hard. This is just going to be cos square phi. No. This will be sine square phi plus mu square cos square phi sine phi cosine phi plus sine phi plus mu cosine phi. This takes care of this, and you end up with V naught 2 V naught, the sine of phi divided by G bracket sine square phi plus mu square phi, and that is the expression for the total time. And you can quickly see this if you recognize that when you do look for the common denominator, it's a difference of 2 squares.
Yeah, so shouldn't it be
Right, shouldn't it be
minus and
minus?
plus?
Yeah.
Oh, yes, minus. Thank you. Any questions, please? Copy. And this was actually, when I wrote this question last year, this was a test question I gave to my former AP physics students, and it was a question in the AP exam. If you look online, it was question number 1 for the free response mechanics. And I was really like, really?
Like the exact same question?
Yep. The only difference was that I had a frictionless surface. They didn't. You can, by now, you should have already downloaded AP questions and put it in a folder in your computer. And you should be looking at those as we are progressing throughout the chapters. If I'm where you, I should have already done that.